Hello everyone, welcome to this session on the derivation of centroid. Now, in the earlier two sessions, we had studied about the derivation of rectangular section and triangular section. To have a small recap, the formula for a rectangular section was if it is symmetric and if x and y axis have been placed towards the extreme side, wherein the base distance of the rectangle is b and depth of the rectangular section is d, then the centroid of the rectangular section would be b by 2, that is d by 2 and b by 2, that is nothing but the centroid. X bar would be b by 2, y bar would be d by 2. Likewise, for triangular section, if the right angle triangular section is supposed to be considered with reference to x-axis and with reference to y-axis, with the base of the triangle as b and height of the triangle as h, then along x direction the centroid distance would be b by 3 from the origin, and along y direction it would be h by 3. So as a resultant, the centroid distance would be b by 3 from the origin, and along the height it would be h by 3. If it is the same centroid distance needs to be considered, like if this is an origin O and the two hypotenuse points named as A and B, with reference to the hypotenuse point A and B, the centroid distance in that particular situation would be calculated as 2b by 3 and 2h by 3 respectively along x and y direction. So these were nothing but the centroid distance that we have studied in the previous session. So continuing further, there are few more sections for which the centroid distances needs to be calculated. These centroid distances needs to be calculated for the reason there will be composite sections that shall come across, like the combination of rectangular section along with triangular section and then with the semicircular section inscribed with a circular section. For that reason, we also need to know the sum of the composite section like semicircular section. So in this particular session, we'll try to learn how to find out the centroid of the semicircle section now. Now here, the centroid of the semicircle section, I shall consider a semicircle which is symmetric about x-axis. That is, it will be easily been bisected into equally two half along the x-axis by respect to x direction. So in this particular semicircular section, the radius will be considered as r and this to be an origin O. So this semicircle is symmetric with respect to the x-axis. Now within this semicircular section, I shall consider a thin triangular section. And this triangular section, if I happen to separate, the triangular section will be represented like this. As it is a radius r, so similarly with reference to the origin, each and every face will be with respect to r at this particular location. This will be with respect to r. The interior angle shall be considered as an angular inclination as d theta. As it will form a curvature at this particular location, and this particular length will be called as r d theta. That is nothing but the curvature length r d theta. So if we go on dividing this particular triangular section in terms of small part, the inclination made with respect to the radius and the curvature portion will be approximately 90 degrees. So as a resultant, this is an elemental area, and area of the elemental is nothing but the area of the triangle. Now this area of triangle shall be considered as a right angle triangle, wherein the base is considered as r and height will be considered as r d theta. So this is half r into r d theta. That is nothing but this particular base distance r and the height as r d theta. And the inclination is nothing but the 90 degrees. So this is an area of the elemental strip, which is a triangular elemental strip. That is area of the triangle, which is half r into r theta, which is r square d theta divided by 2. This is the area of the triangular section. The whole area is a semicircular section, and area of the semicircular section, which is nothing but area of a circle, half it is. So it is pi r square by 2. Now this same circle, this same triangular section is placed at an inclination of theta. If we consider a semicircular region in this particular portion, it makes an angle of theta here. And this particular angle of theta with reference to the x-axis, if it had to be placed, the triangular section had to be placed along the horizontal with reference to the origin, the centroid distance will be 2/3 of r here. With reference to the origin, if it has to be moved from the 90 degrees angle, the centroid distance would be b by 3. if it had to be moved or proceed from the hypotenuse position, the centroid distance would be 2b by 3. Now here instead of b, here it is a radius r that we have been considering here. This is in hypotenuse position, so it is 2/3 of r. When it has been placed along the horizontal direction, it is 2/3 of r. The same inclination when it has been subtending an inclination of theta here. In that particular situation, the centroid distance would be 2/3 of r cos of theta. Likewise, how it is to be calculated here is, if we consider this as y and this distance as x now, that is, if we consider an angle theta here and this as y axis and this as x distance. So cos of theta is equal to x divided by, that is 2/3, that is x by r. So x is equal to r cos of theta. X is equal to r cos of theta. Now this r that we are going to consider is the centroidal distance r. So x is equal to 2/3 of r cos of theta. So for that reason, this x distance is considered as 2/3 of r cos of theta. So x distance will be considered as 2/3 of r cos of theta. Now, as per the first principle, area into x bar is equal to integration x dA. This is what is the value of the centroid along the x direction. That is, A is nothing but the total area of the section, which is the area of the semicircle. X bar is the centroid distance that we need to calculate. Integration is to be considered with respect to the limits wherein the x varies. And dA is the elemental strip that we are going to consider. And that elemental strip is the triangular elemental strip, and the area of the triangular elemental strip is half r into r d theta, which is r square by 2 d theta. Now we need to substitute the individual term. So we shall rewrite this particular equation and then substitute all the terms pertaining to that particular part, which we substitute as a into x bar is equal to integration x dA, which is a is the area of the semicircle, which is pi r square by 2. X bar is equal to integration x, as mentioned earlier, it makes an angle of theta. The centroid distance will be 2/3 of r cos of theta. The same x will be considered as 2/3 of r cos of theta. And area of the triangular section, as it is a triangular section, r into r d theta, that is nothing but the curvature length. So this is r square by 2 d theta. Now we need to simplify this by dividing 2 and 2 gets cancelled up. So as a resultant, r and r will get multiplied. So this equation will be reframed as r cube by 3 can be taken outside. R into r will become r into r square will become r cube. 3 in the denominator is taken outside. Inside the integration term, it will be cos of theta d theta. On the left hand side, the terms will remain as it is, pi r square by 2 into x bar, which will remain as it is. Now we need to integrate this particular term. Integration of cos of theta will come out to sin of theta. But since we are going to integrate, we cannot express in terms of constant of integration. For that reason, we need to substitute the limits of integration. If we happen to check out the diagram that we had considered, the diagram was symmetric about with respect to the x-axis. So with respect to the x-axis, when you consider with reference to the origin, the section of the triangular section, it will vary along the vertical direction like this, upward. So when it varies along the upward direction, the limit here it is plus pi by 2, that is 90 degrees here. The same when it is coinciding with respect to x-axis, it will be 0. When it moves along the downward direction, along the vertically downward direction, the limit will be minus pi by 2. So which indicates the limits of integration that we need to consider is minus pi by 2 to plus pi by 2. So when I substitute here, this will be minus pi by 2 and the upper limit will be plus pi by 2. So these are nothing but the limits of integration. I cannot consider from 0 to pi by 2. If I happen to consider from 0 to pi by 2, which indicates I will be omitting the bottom quarter circular part now. But since I am deriving the derivation for the semicircular part, the triangular section will vary along the upright vertical portion and upright downward vertical portion. So which indicates this triangular portion will coincide with respect to the vertical y-axis, which will be theta is equal to plus pi by 2. Bottom vertical y-axis, which will be theta is equal to minus pi by 2. So for that reason, the limits of integration will be minus pi by 2 to plus pi by 2. So we need to simplify this. Pi by 2, here we have r square, on the right hand side we have r cube. So both can get cancelled up. So x bar you can keep it as it is. On the right hand side it will be r by 3 as it is, because r square and r cube get cancels up, and on the right hand side r will be kept as it is. Integration of cos of theta will be sine of theta. Then substitute the integration term minus pi by 2 to plus pi by 2. Now we need to substitute this particular part, that is nothing but the limits of integration. And when we substitute, the left hand side term, keep it as it is, pi by 2 into x bar as it is equal to r by 3 again as it is. And here this will be sine of pi by 2 minus of sine of minus pi by 2. Okay, these are nothing but the limits of integration that we get after we substitute. So sine of pi by 2 means sine of 90 degrees. Sine of 90 degrees is 1. Minus of sine of minus of pi by 2 will be minus of 1. So in the left hand side again pi by 2 into x bar as it is. So this part pi by 2 into x bar is equal to r by 3 as it is. 1 minus into minus will become plus 1. So this will be pi by 2 into x bar r by 3, 1 plus 1 will be 2. So this is pi by 2 x bar is equal to 2r divided by 3. So x bar will be equals to 2 into 2 will become 4, and 4r divided by pi will come in the denominator, so this will be 4r divided by 3 pi. So this is nothing but the formula for semicircular portion when it is symmetrical about x-axis, that is when it is symmetrical about x-axis. X value of the centroid will be, with reference to y-axis, this y will be originated here. With reference to the x-axis, the centroid distance will be 4r by 3 pi. This particular distance would be 4r by 3 pi. So if we consider the same semicircular portion with reference to the origin here, that is if I draw the semicircular portion again with reference to a certain location. Now if this is a semicircle, this is symmetric about x-axis, and if the x-axis and y-axis have been placed far away location, that means y will be d by 2 or r and x will be 4r by 3 pi if it is symmetric about x-axis. Likewise, if the same semicircle, if I happen to keep it in the upright fashion, which indicates it is symmetric about y-axis, in that particular situation, if x-axis and y-axis have been placed at a faraway location, in that particular condition, x would be d by 2 or r and y would be 4r by 3 pi. So when we are moving from the straight line, the centroid distance is 4r by 3 pi. When we are moving from the straight line, the centroid distance is 4r by 3 pi. On the same hand, when we come across the curvilinear portion, when you come across the curved portion and then proceed towards the centroid, in that particular condition, the formula would be total distance is r, and this remaining left out distance would be r minus 4r by 3 pi. That is, from total distance r, you are going to subtract the 4r distance. So this formula would be r minus 4r by 3 pi. Similarly, here at this particular location, total distance here, the radius is r, and when we are considering the centroid from the origin, from the curvilinear portion, this particular distance would be r minus 4r by 3 pi. The same semicircular portion can be oriented in any direction. Now, as of now, in the derivation, semicircular portion is oriented towards the right hand side. If the same semicircular portion is oriented towards the left hand side, then again this would be y would be d by 2 or r and x would be 4r by 3 pi. Same semicircular portion when it is inverted in this particular fashion, symmetric about y-axis, x would be d by 2, which is r, then y would be 4r by 3 pi. So what it says is, if semicircle is symmetric, we'll write it as symmetric here, and we'll put the value as x and y. If it is symmetric about x-axis, then y would be d by 2. Then x will be 4r by 3 pi. If it is symmetric about x-axis, then x will be 4r by 3 pi. If it is symmetric about y-axis, then y would be 4r by 3 pi. Likewise here, if it is symmetric about y-axis, y would be 4r by 3 pi. If it is symmetric about y-axis, y would be 4r by 3 pi. So straight away we can write it as, if it is symmetric about y-axis, y formula would be 4r by 3 pi, y is 4r by 3 pi, then x would be d by 2. So this is very, very important when you take out the formula related to the composite section. So we need to identify whether the semicircle is symmetric about x-axis or y-axis. If it is symmetric about x-axis, then x would be 4r by 3 pi and automatically y would be d by 2. If it is symmetric about y-axis, then y would be 4r by 3 pi and x would be d by 2. So this is how we are supposed to find out the centroid of a semicircle when it is symmetric about a particular axis. And these formulas are very, very important. It is x is equal to 4r by 3 pi or x is equal to r minus 4r by 3 pi is very, very important when we start solving these numerical problems related to the centroid, and especially when it is a composite section. Thank you. Have a nice day.